Everybody, very good evening all, and very warm welcome to the session. I hope that you are all doing great with your preparation. Your CSIR NET examinations are nearly very close to you, and in this regard, seriously, you all might be very busy with your preparations. So today I'm going to help to revise the most important and repeated questions for your CSIR NET examination. Right. So this is what we are going to see today. We are going to have a detailed look into the repeated questions for your CSIR NET. Yes? Okay, guys. So this is little bit about me. If at all you have not yet known me, I have done my PhD in Biomaterials. Okay, so I do have 15 papers to my credit. So my field is with Biomaterials. I was working with scaffolds for tissue engineering, and I am a plus verified educator at Unacademy. I'm teaching for the past 10 years with a great band number of students, and this is my profile. So if at all you have not yet followed me at Unacademy, please ensure that you are going to follow me. Fantastic. So let's make a move towards today's repeated question. Right. So the first area, the most green area, always questions will be coming from this area. This is going to be from your biochemistry. In biochemistry, we have a lot stream of questions, but I have sorted out the most important repeated questions for you. So one such thing, it is going to be your calculation of the PI. Yes, Naresh. Good evening. Yes, Himanshi. Very good evening. Right, guys. So let us make a move towards the first most important and the repeated PYQ. To your information, this question was asked by December 2016. You might note that even in the recent days, that is your past 2022 question paper also, you had a similar question regarding this calculation of your PI. Right. So let us take this question. The question goes like this. Choose the most appropriate pH at which the net charge is 0. Okay. So at what point your net charge will be 0? What is it called as? Nothing but it is called as your PI. What is PI? PI, it is going to be your isoelectric point, isn't it? Yes. Yes, Selvamani, good evening. Okay. So what is PI? PI is going to be this isoelectric point. Okay. So any difficulty in this question? Usually you will get PI for two values. It will be quite easy for you to solve, right? But in this question, the difference is that you have got 3 pKa values. Okay. So that is the trick in this question. If you are able to solve this, well and good. So I'll set the timer for you. Okay. So I'm going to give like 1 minute time for you. Okay. So within that time, you should be able to complete it. So let's check out whether you are able to solve that. Come on, guys. You can check it. Yes. Try to solve this question. If you are not able to do, I'll help you to answer this. Yes, everybody in this class. Try it out with this question, guys. Yes. So if it is not visible, I am just writing. Your pKa 1 is 2.02. Your pKa 2 is, what's that? 9.94. And your pKa 3 is 3.80. So calculate the PI. Everybody should try. Yes, guys. I have written it, Selva. I think now it is visible. 9.94. This is 2.02. 9.94. 3.80. Okay. Did you all try it out? Is it visible? Should I rewrite it one more time, guys? Good, Selva. Yes. What about others? Everybody else in this class? Did you get the answer? Come on, everybody. Did you try out? Did you know the trick behind this question? Yes? Okay, don't worry. I'll tell you, if at all you are having 3 numbers in your pKa value, the methodology is going to be different. Yes, Himanshi, good. Yes, learn with fun. Fantastic. So, if at all it is going to be a 3 numbered value, you are going to, yes, good evening. So, it is going to be a different methodology to follow. So, what you have to do is that you have to check out with this pKa value. So, let us take this. Here the pKa value is 2.02. Oh, 0 is not visible. Okay, I'll write it by hand only. That is better, I guess. Yes. Oh, yes. Oh, sure, Bharti. Yes. Oh, sure. Definitely. You can see it later as well. Don't worry. Okay. So, the next pKa value is 3.80. All right. Fine. So, the next one is 9.94. So, what is the good trick that I will tell you is that you have to categorize this PI. Okay. So, you are going to take whether it is going to be below or above. Okay. So, let's take 7. Okay. Right. So, if it is going to be 2.02, it is below 7. Right. If it is 3.8 also, it is below 7. But if it is going to be your 9.94, absolutely this is above 7. Right. So, among these three, you are going to take the odd man out. So, which is the odd man? This 9.94 is going to be the odd man. So, you are going to eliminate them. Yes, these two are acidic. This is only basic. So, we don't want that fellow to interfere with our answer. So, we are eliminating him. So, we have only two values now. What is that? 2.02 and 3.8. Okay. So, add and see what is coming now. 5.82. Right. So, this is going to be your pKa 1. Yes, Monica, correct? pKa 1 and 2, you just take it. Take an average. Yes, 2 2s are 4. Right. So, just a moment. So, 2 2s are 4, remainder 1. So, it is going to be, which one now? Just a moment. Yes. 9 2s are 18. 2.91. Hence, B is going to be the correct answer. Got it, guys? So, is it simple to you now? So, the basic rule is that you are going to categorize the data. Okay. So, you know that only if 2 are there, it is easy for you to calculate. If it is going to be greater than 2, you are going to club the values and you are going to eliminate the odd one. Okay. Right. So, shall we take one more question and shall we test it? Yes. I told you these are the repeated question. Okay. Right. So, let's see when this question is again repeated. All right. So, is this question visible to you? This is regarding your February 2022 paper. Yes, in this February 2022 paper also, you got a similar questions. Don't worry guys, I'll write the values for you. So, pKa 1, it is going to be, I'm just rewriting as this visibility is less for you. pKa 1, it is going to be how much? 2.16. Okay, right. Next is pKa 2. So, what's going to be this pKa 2? It is 9.06. Right, fine. Next is pKa 3. So, what is that pKa 3? It is 10.54. I hope that the values and all are now visible to you. Everybody in this class, these pKa values are visible. Right. So, now they are asking what is the PI. To the top, they have given that this is going to be for your lysine. So, that is another interesting clue. Right. Thank you, Himanshi. All right, everybody. Come on, guys. So, will you try this question? You want timer or you'll try not own? You want timer? Or you will like to try on your own only? Yes, everybody in this class. I want everybody to participate. Come on, guys. It's a simple question. Yes, a repeated question also. See? From 2016 and 22 it is repeated. Yes? Okay. So, find it out. Yes. Everybody should try. Come on guys. Fantastic. Easy one only, no? Yes, Selva, Monica. Fantastic. Keep going guys. It's very, very simple and easy. So, now let us see what is the trick here. Okay, right. So, now you have three values. Okay. So, one is 2.16. You are going to compare it with 7. So, 2.16 is lower than 7 or higher than 7? It is lower. That means it is acidic. Right. This is higher. That means it is basic. This is also higher. That means it is basic. Now, who is the odd man? Among the three, who is the odd man now? Yes, everybody in this class. Acidic is odd man. So, I don't want him. I don't want any odd man here. Odd man out. Right? Fine. So it is going to be 9.06 and 10.54. So if I want to take out my PI, I'm going to take the average of these two. So shall we just check out what is the total number? 10, 6, 19. Right? Fine. So it is going to be 19.6 divided by 2. So what is going to be this 19.6 divided by 2? Yes, everybody. Come on. So it is going to be, yes. So 19.6 is pKa 1 plus 2 ma. pKa 1 plus pKa 2 divided by 2. This is going to be my PI. So the formula is pKa 1 plus pKa 2 divided by 2. Okay, right. Yes. So this is the formula. Got it now? Right. So it is going to be 19.6 divided by 2. So it is going to be 9.8. Got it now? Everybody in this class? Did you get it? Henceforth, D is only going to be the correct answer. Everybody is thorough with this? Yes? Okay, guys. Fine, fine. I hope that this is clear. Okay, good everyone. So let's make up a move towards the next question. Yes, so this is going to be on your molecular biology. Okay, so this is clear now regarding our biochemistry. That particular question is clear, I guess, right? Okay, just a moment. Yeah, so this one is done. Okay, so let's make a move towards the next question. How it is readable? So the visibility is there or not? If not, please kindly increase your settings. Yes, so please go to that settings and then check out with the quality. Go for auto recommended and also check with your this pixel. Yes, and then make it off such that you increase the quality. You use the higher picture quality, definitely it should be fine for you all. All right, fine everybody. Okay guys, so let's make a move towards the next important question. So this is a match the following. Similar questions have been asked in the next thing also. So please take this seriously. Definitely a lot number of questions will be coming on this. So this is previously asked in 2019. Okay. So let us see what is this question on. Okay. This question says something about your enzyme as well as the chemical group that is being transferred. Right. So the first one is coenzyme A. Yes. What is the first one? It is the coenzyme A. Okay. The second one is flavin adenine dinucleotide. Flavin adenine dinucleotide. Third one is pyridoxal phosphate. Next it is nicotinamide adenine dinucleotide. Okay, you are going to match them with the chemical groups that is transferred. So this is coming from your enzymes. Enzyme is another important subtopic for your preparation. Don't miss out. So it is going to include the electrons, acyl group, hydride and amino group. You are going to match and tell me which is going to be the correct one. Yes, everybody in this class, try it out. If you get it, please do let me know. I hope that the slides are visible and now you can see, I guess. If not, I am just reading out for you. It is going to be your coenzyme A, FAD. Okay, I'll write it if you're not visible. CoA, FAD, pyridoxal phosphate, NAD. Okay, right. Good, everybody. This side, it is going to be on your S-Rumi, electrons. This is acyl group, hydride ion, and then amino group. Okay, fantastic, everybody. Come on, thank you, Selva. Thank you for the comments. Okay, great, everybody. Fantastic. So, which is going to be the correct answer? Yes, Selva and Rumi, you're right. It is going to be your option B, right? So, coenzyme A, it is always with your acyl group. With one option only you can pick, seriously, right? So, yes, Rumi, good. So, the next one, it is going to be your flavin adenine. FAD. Okay, so this FAD has always two options. One it may go with E and another one it can go with H. Both ways it is possible, but the majority of the ones, yes, it is here in this question, it is with your electrons. Right, fine. And the next one, it is pyridoxal phosphate. It is PAP. Pyridoxal phosphate is with your amino group, PAP. And NAD, it is going to be your NADH, hydride ions. Got it, everybody? Yes? Okay, fantastic, ma. So I hope that this is clear. So let's make up a move towards the next question. Okay, fine. So see, similar question was asked in 2017. Okay, so almost the same type of question. It was asked in 2017 also. So you are going to match the coenzymes that is given in this column 1 with your column 2. Will you try this out? Yes, everybody in this class, just now we did a similar question. Shall we try it out? Yes or no? I want everybody in this class to try this. Yes, Monica. Good, good. Come on, everybody. I want everybody to try this question. Yes, guys. Take it out, take it out. Compare and give the answer. Coenzyme A, FAD, same pyridoxal phosphate. Only one they have changed. It is the thiamine. Isn't it? Apart from thiamine, all others remain the same. Okay. Right. Good. So with the coenzyme A only you will fix, isn't it? So A is 4. With that only you know that A is the answer. Fantastic, everyone. So what about your FAD, isn't it? So it is going to be your FADH, right? Because electron is not given, so we go for H. If electron is given, you will go for electron. And then pyridoxal phosphate. So pyridoxal phosphate, it is going to be with your amino group. And what about your thiamine? Thiamine, it is with your aldehyde group. Got it, everybody? So this is clear. So there are repeated questions. It doesn't mean that CSIR is asking somewhere from elsewhere. Seriously, repeated questions are there. So that is why always there is a need to look out the PYQs. Okay. So don't forget to revise the PYQs. Yes. So PYQs are very, very important. Okay. So don't ever tend to miss out the PYQs. One such good instance, it is going to be with our concept of developmental biology. Okay, so if you take this, my god, sorry guys, it's running, it's a new system, it's running off, so just give me a minute, it will be back. Yes, nice, everybody. I think this is done. So in biochemistry we have done 2 major repeated questions, right? Yeah. So now we will jump into molecular biology. Okay, good, everybody. So in molecular biology, the first one, it is regarding the match the following of your enzymes and its function. See, this is also a February 2022 question. Enzymes and its function. Yes? Very good, everybody. Come on, guys. So number 1, it is about your DNA topoisomerase 1, topoisomerase 2, polymerase epsilon and polymerase delta. Yes. Okay. So please check the quality of your thing. Go to settings. So go for your quality. In that, please do set up with this resolution. You can go to this advanced resolution. Yes. So if you go to this advanced resolution, you will get it. Yes. If it is blurred, please go to that. The settings will be clear. Okay. So just click the settings in the YouTube and then go to this quality. In that quality, go to advanced and then select 1080p, 1080 pixel. Okay. So if you go to that, you will get a better image quality. Did you check it now? After doing this, did you check it out? Because in my mobile, it is working fine. Okay. So anyhow, I'll read this for you. Don't worry. So it is topoisomerase 1, 2, polymerase epsilon and delta. This is going to be the synthesis of Okazaki. Don't worry, guys. Next time I'll put another one, and it is the leading strand, double stranded break and ligation, and then single strand nicking. Okay. So now you are going to, yes, and now you are going to match them with the given options. Okay. Fantastic, guys. Right. Okay. So now it is visible. It is clear. First one is Okazaki fragments. Okay. Second one, it is the leading strand. Third one, it is a double stranded break. Fourth one, it is the single stranded nick. Okay, right. Come on, everybody. Think and answer. I hope that now it is quite okay, I guess. Yes, everyone. Is it quite okay now? Yes, Monica. Come on, everyone. Yes. Done? So, generally, I have given you a hint about this epsilon. E is there, no? E, it is for your leading stand. Okay, right. Next is delta. It is for lagging stand. So, who is lagging? It is going to be this Okazaki. Okay, so Okazaki is only going to be the lagging fellow. Okay, so who is lagging? It is going to be the Okazaki. Okazaki is only going to be your lagging stand. Right? Fine. Yes, everybody. Okay. So, based on that, can you eliminate any options? Check it out. C, it is for 2 and D, it is for 1. Yes. C, 2 and D is 1. So, maybe this only one option you can eliminate. But other 3 are remaining. So, we have to go with the topoisomerases 1 and 2. Yes, everybody. So, what about your topoisomerases? Topoisomerases, of course, they will create the break. Okay. So, this is going to create what kind of break? Who is going to create a single stranded nick? And who is going to create a double stranded nick? Exactly. Yes, everybody. So, the correct answer is going to be your A only. Okay, right. So, as far as your topoisomerases are considered, you have 2 types of topoisomerases. Okay, so this one, it is going to create your single stranded nick and the other one is going to create your double stranded nick. Okay, so as far as this topoisomerases, one is considered. One is going to go with the single stranded. One, it is with the single stranded. 2 is only with your double stranded. Got it, everybody? Yes? So, understood this about your topoisomerases? Everybody in this class? So, shall we summarize this one more time? Okay. So, always remember, single stranded is 1. Double stranded is going to be your 2. Got it? Everybody in this class, did you understand this? My God, my slides are running. Kindly bear with me for a moment. Okay, just a moment. Sorry for the little bit glitch. Okay. Yes. Done. All right. Don't worry, ma. So, 1, it is meant for your single stranded nick. 2 only, it is meant for your double stranded cut. Okay. Right. So, only 2 things. So, topoisomerases 1, it is going to be for single strand, and then topoisomerases 2, it is for your double strand, and then your epsilon E, it is for your leading strand, and delta, sorry, it is for your lagging strand. Okay, a simple match the following was asked. So, this was your February 2022 question paper, not a very old one, a recent one only. Okay. So, please be aware of all the enzymes that is involved in your replication. Apart from this, whatever enzymes are involved, ligases, right? Fine. Helicase, okay. And then you have your primase, okay. So, all these may look simple. It may come in another match the following or some kind of things also. So, please be ready with that. All right. So, let's make a move towards the next example of similar kind of match the following that may be asked in your examination. So, this is a GATE question. Okay. So, this is going to be a GATE PYQ. So, let us see this question. A similar kind was asked regarding your RNase P, RNase H, snRNA, and then CSTF, cleavage stimulation factor. Okay. Right, everybody. So, is this visible now? Polyadenylation, splicing, ribozymes, DNA, RNA hybrid. Yes. Come on, everybody in this class. RNase P. Where did you study this RNase P? Somewhere in your tRNA processing. Yes? Okay. Then, where did you study this RNase H? To remove your hybrid? Somewhere you read? What about your snRNA? Yes, Monica. snRNA, it is what? It is in your spliceosome complex. Almost I revealed the answer. Yes, Tasneen, welcome. CSTF, cleavage stimulation factor. Obviously, that is going to be for your cleavage stimulation. No? So, this is in your capping and tailing, poly A tailing. Yes, tailing. Your cleavage stimulation factor, CF1, CF2, and then your cleavage stimulation factor. Yes, absolutely. Yes, Tasneem. So, RNase P, it should go with your ribosine. It trims your leader peptide. Okay, so that is going to be that. RNase H, it is your DNA RNA hybrid gone. Okay, so snRNA, it is what is involved in splicing, and cleavage stimulation factor, it is with your polyadenylation, right? So which is the correct answer? 1 is 3. Okay, so by that only these two get eliminated, and Q is 4, so A got selected. Got it? Everybody in this class, is it clear? So in molecular biology, you are getting the match the following questions. That is the bottom line. Okay, fantastic. Right, so let's make a move towards the next subtopic. I'll tell you. Yes, it is going to be your developmental biology, where you get the maximum repeated questions. Maximum repeated questions do come from your developmental biology. So don't miss it out. Okay, right. So the question is like the group of cells. Okay, so this group of cells of your amphibian blastula, okay, that is capable of inducing. Okay, so what this is doing? This cell is inducing your organizer. So what your cell is doing? It is inducing your organizer. So who is actually inducing the organizer? Is it going to be the Henson node or Newcomb center, or it is the dorsal blastopore lip, or it is going to be the hypoblast? Yes, everybody in this class. Yes. Good, everybody. So who is going to induce the organizer? Fantastic, everybody. So who is inducing the organizer? None other than the Newcomb center. Okay, so I would like to tell you few basics about this. So as far as this is considered, okay, so you have 3 different layers. Okay, so what is the lower layer called? Yes, everybody, what is this lower layer called? It is the endoderm, right? Fine. So what is going to be this middle layer called? It is the mesoderm, right? And what is going to be the top layer called? Top layer is called as the ectoderm. Okay, so now I'm going to divide it into half. What is this right side called as? What is this region called as? Is this dorsal or ventral? Yes, everybody, tell me. Yes, very good, Tasneem. Yes, Selva. Yes, Rumi. This side you call them as the dorsal. This side you call them as the ventral. Got it? Yes, everyone? Is it clear? So this side you call them as the dorsal, and that side you call them as the ventral. Fantastic. So now, where is going to be your Newcomb center? I am saying that Newcomb center is here. True or false? Where is your Newcomb center? Newcomb center. Okay, where it is present? It is present in your S. Meghna, S. Elva, it is present in your endoderm. Absolutely correct. This is where your Newcomb center is going to be present. And what this? Yes, I'll tell you. This is the Newcomb center. So this Newcomb center is present in the vegetal endoderm. Got the point? Where this Newcomb center is present? It is present in the vegetal endoderm. What is this middle region? This is the dorsal mesoderm. This is the dorsal endoderm. Okay, this is the dorsal mesoderm. So this dorsal mesoderm, okay, so this dorsal mesoderm is only going to form your Spearman organizer. Got it? So the dorsal mesoderm is only forming the dorsal blastopore lip. Okay, but this is only the organizer. This organizer itself is induced by this endoderm. And who is present in this endoderm? It is vegetal opposite is animal pole, ma. Yes, Selva. This is vegetal pole, no? This is animal pole. Got it, Selva? Okay. Yes. Yes, Monica. So this is clear now. Yes, Tasneen, is it clear now? Okay, fantastic, guys. So the Spearman organizer must be present in the mesoderm. Everybody got it now? Yes. So the Spearman organizer is mesoderm. So what this Newcope center is going to secrete? Can you tell me what this Newcope center is going to secrete? That's okay, Selva. So the Newcope center is going to secrete your beta-catenin. Okay, my next question for you now. Is beta-catenin an organizer? Everybody in this class, tell me. Do you think that beta-catenin is an organizer? True or false? Tell me, ma. Beta-catenizer, I am saying it is an organizer. True or false? No. It is not at all an organizer. Okay. Yes. Beta-catenin. Many of you think that beta-catenin is an organizer. No, it is wrong. Beta-catenin is not an organizer. Organizer should be present only in your mesoderm. It is not your endoderm. So who is going to be the organizer then? Okay, beta-catenin is not the organizer. Beta-catenin is simply inducing my mesoderm. Mesoderm is only the organizer. So what are the organizer molecules? I'll tell you. The organizer, it is what is being secreted by whom? Your Spearman organizer. It is all the dorsalizer. Who are all the dorsalizer? You have studied this noggin. Yes? Noggin. You have studied noggin? Noggin is an organizer. Yes. Absolutely. You have studied this cordon. Cordon is an organizer. You have studied this follistatin, Dickenkoff. All these are going to be the organizer. But beta-catenin is not at all an organizer. Beta-catenin, it will induce the organizer. So, the organizer will secrete these molecules. This is only determining your dorsal fate. That is why this fellow is regarded as the dorsal lip of the blastopore is regarded as the organizer, but not our Newcope center. Newcope center, it is going to be an inducer. That's all. What Newcope center will do? Newcope center is simply going to induce. This is the Newcope center. No, this fellow will simply induce this mesoderm. Mesoderm is the original organizer. He is only going to secrete all those stuff. Got it? Is it all clear to you now? Shall we take one more question such that you will get clarity into this concept? Come on, guys. Okay, so I hope that now it is fine. So you have three layers: ectoderm, mesoderm, and then endoderm. Okay, and then your Newcope center is present. Okay, so see, you are going to state whichever statement is true or false. I am going to go statement wise only. Okay, right. So which one of the following statement is correct? Statement number 1 says that the organizer itself, it is induced by the Newcope center. Till this it is true or false? The organizer is induced by the Newcope center. This first half is true or false? Yes. First part, the organizer, it is induced by the Newcope center. True or false? True, no? First half is true. See the second half. It says that it is located in the dorsalmost mesoderm. Where is my organizer located? Is it located in the dorsalmost mesoderm? No. Dorsal part is correct, but it is located in the endoderm. I told you, no. If you take your embryo, this is going to be your endoderm. This is going to be your mesoderm. This is going to be your ectoderm. And this is where your Newcob center is located. It is located in the endoderm. It is not at all located in your, it is not located in your mesoderm. Mesoderm is meant only for the Spearman organizer. So the first statement itself is wrong, gone, right? Okay, so let's make a move towards the second statement. Let us see that the organizer functions like secreting proteins like noggin, chordin and follistatin. This half is true or false? Spearman organizer is secreting noggin, chordin, follistatin. So this is all right, fine. See the next statement. These are all going to block your BMP. What statement they have said about BMP? BMP is the bone morphogenetic protein. Where this BMP will be more? Will it be more in your dorsal side or your ventral side? Which side your BMP will be more? BMP should be more only in your ventral side. Isn't it? They have given that it is going to be in the dorsal side. No. Remember, BMP is a ventralizer. So, dorsalizer, your Spearman organizer is secreting. Likewise, BMP is ventralizer. You are going to inhibit or block the BMP. That is why this ventral is stopped. It will become dorsal. But read this question carefully. This states that BMP will dorsalize the mesoderm. Thereby, this is wrong. Okay? Got the logic now? Everybody in this class, did you get the logic now of how I eliminated this point? This is all because of this single term dorsalize. It should have been ventralize. Very, very tricky question, I know. But still it is a repeated concept, so in depth they will ask. Okay, the next one. In the presence of BMP activator, the ectodermal cells, it will form neural tissue. Any possibility? BMP it is for your BMP it is for your ventral. So neural is your dorsal. So this is also eliminated. So obviously which should be your right answer? It should be D. Let us see what is this D. It says that your Wnt signaling, it is going to create a beta catenin along your anterior posterior axis. So it is only forming this neural tube. So it is only regionalizing this thing. Absolutely correct. So Wnt along with your beta catenin, it is only going to form your neural tube or the neuralizer. So that is what is going to be the correct answer. Okay. So very carefully you have to read each and every sentence. See, so many tricks they have kept it inside. Okay. So let's take the next question. The dorsal most vegetal cells which is capable of inducing the organizer, it is called as Newcob center. You know that. The question is, it is marked by the presence of what? So Newcob center is rich in chordin, beta catenin, goosecoid, nanos. What is this? Thank you, Selva. So what is this rich in? Newcob center is rich in what? Yes, Rumi. Newcob. See how many questions have come from a single topic? Yes. We have seen biochemistry, we have seen molecular biology, but see this developmental biology fellow, these questions are being asked every time. So be clear in it. Yes, everybody, absolutely. Beta catenin is what is present in Newcob center. And one more pathway I just want you to just recollect. Why it is running? Just a moment, guys. It run off. Okay. So, too many questions there. Just a minute. My God. If I click something, it is running off. Kindly bear with me for a moment. Okay, just a moment. Yes. Okay. So now one more point I would like to teach you. Yes, it is going to be that. So your endoderm. Okay. So this endoderm, it is in your vegetal side. This is your animal side. It is going to have your ectoderm. Okay. Right. So who is forming this neural? Dorsal or ventral? Neural is dorsal or ventral? Oh, Tasneem, definitely. Yes, Tasneem, my lecture time is the same, 6 p.m. session. Okay, right. Nice, Tasneem. Okay, so the neural, it is going to be dorsal or ventral? Yes, everybody in this class. Come on, ma. Yes, neural is dorsal. Skin, dorsal or ventral? Skin, dorsal or ventral? Yes, skin is ventral. Okay, this is the basic point. Good, fantastic. Yes, Rumi, Tasneen, Selva, keep it up. Yes, Monica. Good. So now we are going to see the next point where your beta catenin is synthesized. Synthesized in the endoderm. Okay, right, fine, very good. Yes, Tasneem. So after synthesis, it is going to get accumulated somewhere. Okay, site of synthesis, it is in the endoderm, but your beta catenin, it is going to be accumulated. Okay, so where it is accumulated, right? So where your beta catenin is accumulated, it is accumulated in the mesoderm. Got it, everybody? So this is what it is accumulated. It is accumulated in your mesoderm. Okay. Yes. So this accumulation takes place in the mesoderm. Even though the synthesis is taking place in your endoderm. Don't move. The synthesis is taking place in your endoderm, but this accumulation is what is taking place in your mesoderm. Got it? Okay, fantastic. Right. So let's make up a move towards the next question. Okay. So now there is one more fellow that is present. He is called as GSK3. Very naughty fellow. What he will do, you know? He is going to degrade. So what he is going to degrade? This GSK3, it is an enzyme. Okay, so what this enzyme is going to do? This enzyme, it is going to degrade your beta catenin. Okay, right. So beta catenin is meant for your dorsal side or ventral side? Beta catenin is meant for your dorsal side or your ventral side? Come on, everybody. For what your beta catenin is meant for? Beta catenin is meant for the dorsal side. Okay, but this fellow GSK3, he will degrade your beta catenin, no. So where he should be rich in? GSK3, it is an enzyme that is going to degrade your beta catenin. Where this GSK3 should be rich in then? Yes, it should be rich in your ventral side. Okay, got it? Is this point clear to everybody in this class? Yes or no? Everybody in this class, please let me know whether you are clear on this or not. If not, just let me know. I'll tell you one more time on this. Okay, right? Yes, got it clear? Okay, so please understand this. This is a very, very important concept. Okay, right. So you have to understand this. Seriously, it is going to be very much helpful for you. So one more time, I'm just repeating it. Okay, so you have your total things here. Okay, so you're going to have a look at your things, right? So yeah, you are going to contain your this thing. So let us see that in your dorsal region, who is there? Your beta catenin is there. Okay, so beta catenin is there in your dorsal region. So what will happen to this level of your GSK3? It should be low. Okay, because it should be more, no, so this level should be low, right? But as far as your ventral region is considered, okay, so if you take your ventral region, so in your ventral region, what should happen? So if at all I am talking about your ventral region, so what should happen to your beta catenin? It should be low, right? So if my ventral region beta catenin is low, this GSK3, it should be high. Okay, indirectly it says you something, right? In this dorsal side, GSK3 is low. Why it is low? Because it has an inhibitor. Okay, so this is what is called as D-shield protein. What is that called as? D-shield protein, DSH, D-shield protein. This D-shield protein is only going to inhibit your GSK3. What this D-shield protein is going to do? This D-shield protein is inhibiting your GSK3. Understood? Is this clear to everybody in this class? Right? So shall I ask you a few questions? You are going to tell me whether it is true or false. Yes, everybody in this class. Are you ready for this? Yes? Okay, fantastic guys. So you are just remembering 2 points. So now let us take the next question such that you will recollect and collect it. Okay. So in case of Xenopus, which will make the Newcop center and the SPMAT organizer? Okay. Good everybody. This is a simple question. We have already seen this concept. See how many questions have been repeated from the same concept, no? Every year almost you get one question from this concept. So don't miss this out. Okay. So in case of your Xenopus, your Newcop center and SPMAT, it is being formed by which of the following respectively? Endoderm and mesoderm, mesoderm and endoderm, endoderm and ectoderm, ectoderm and endoderm. So what it is going to form? Everybody in this class. Make it out, make it out. Yes, guys. Come on, everyone. So, Newcop center is going to be your endoderm. Very good. Yes, Selva, Rumi. Fantastic. Right. And then SPMAT organizer is going to be your mesoderm. Right. Got it? Is this point now clear to everybody in this class? I hope that you don't have any doubt on this. Okay. So, this blastopore region that secretes the BMP inhibitor and it is dorsalizing. Who is the dorsalizer? Is it going to be this brackets cleft? Is it going to be your Newcop center, SPMAT organizer or Henson node? Henson node, papitis from chick. Okay. And brackets cleft, it's not here. Embryonic shield is in the fish. And here which is going to be the correct answer of BMP inhibitor? And the dorsalizer. It is going to be none other than our SPMAT organizer. Yes, everybody, did you get it? It is going to be from your SPMAT organizer. Clear or not? Yes, everybody in this class. Clear? So much of questions are being repeated, ma, from the similar concept. Okay. Yes, Tasneen. Yes, Selva. Very good. So, next one. So, the next is another important question. Let us see. Okay. So, you are injecting noggin. What is this noggin? Who secretes the noggin? Noggin is secreted by your organizer. Okay. So, let's take this question. The injection of noggin mRNA in the cells that will become the future ventral side of your frog embryo. It is going to mimic the organizer that is grafted to the ventral side. So, what does this experiment demonstrate? So, what this experiment is actually telling you about? Okay. So, it says that noggin is a transcription factor. Noggin induces ventral fate. Noggin is involved in the organizer fate. Noggin is required to induce a secondary axis. So, which of the following statement is going to be correct? Yes, Tasneen. Noggin, it is not at all a transcription factor. It is a paracrine. What is noggin? It is a paracrine factor. Okay, you studied justacrine, paracrine. No, so this is a paracrine factor. So, definitely A is not the answer. Okay, the next one. Noggin, it is going to induce the ventral fate. Is it? Never. Noggin is the dorsalizer. Never it will induce the ventral fate. Yes? So that is also eliminated. So noggin is an organizer and already in your dorsal side noggin will be there. Again you are injecting the noggin into the ventral side. So this ventral side will make a transformation to the dorsal. Okay, so there will be, yes, Hussain, correct. So there is going to be two dorsalizers, right? So two dorsal side. So your option B with C and D, it is going to be the correct answer. Got it, everybody? So take home message. Noggin, it is a paracrine factor, not a transcription. So noggin is only for dorsal but not for ventral. Noggin is involved in the organizer. If you inject the noggin into the ventral, that ventral will become dorsal. So you will get two heads, right? So that is what is the secondary axis. So the correct answer is going to be B. Oh, sorry guys. Just a moment. I don't know why it is running. See here, just wait for a moment. Okay, so let's take this question. Okay, the presence of beta catenin, okay, in the nuclei of blastomere in this dorsal portion of this amphibian embryo, it is one of the determinants for laying down this dorsoventral axis. So what will be the outcome of expressing a dominant negative form of GSK3 in the ventral cell? Just now we saw about your GSK3, isn't it? Right? So now think and tell me what will happen if this GSK3, it is going to be mutated down, a negative mutant. That means there is going to be no GSK3 at all in the ventral side. So what will happen? The dorsal side will be ventralized. The secondary axis will be formed. The primary organizer will not be formed. The embryo will develop normally. Got the point? Everybody in this class, think and answer a simple question for the day. Yes, everybody. Come on, everyone. Yes. Done? Okay. How many of you got it? Simple one only. Yes or no? Everybody in the class, make it out, make it out. Shall we see the solution for this? See, your beta catenin must be present in the dorsal region. All right. So now, in your dorsal region, how will be your GSK3? In the dorsal region, GSK3 will be inhibited. Who will inhibit? Who will inhibit my GSK3? It is going to be your D-shield protein. Okay, this is fine. Right. Yes. Okay. So the next one, this is going to be your ventral fellow. Right. In this ventral fellow, actually, how should be your GSK3? It should be more. Okay. So in this ventral side, this GSK3 should be, I'm hiding. Okay. This should be more. But now in this experiment, here also they have removed this GSK3. So even though it is a ventral region, this GSK3 is inhibited. So this will also behave like a dorsal, no? So it will have two dorsal, right? That means the secondary axis will be formed. Okay? Understandable? Is this thing clear to you? Everybody in this class? Any doubts in this? Please do let me know. Yes, Himanshi. Okay. Good, Silva. Yes, Rumi, Tazneen. Who else there? Come on, guys. So let's take a move towards the next question. See, this developmental biology, how many questions are being repeated from the same concept? Isn't it? All right. Fine. Okay. So, which protein it is secreted by the organizer which induces the neural tissue by inhibiting this BMP? Yes, Richa. Come on, everybody. Which protein is secreted by this amphibian organizer which is inducing the neural? I told you, your organizer, dorsal, it is going to induce only your neural fate. right? It is all going to induce your neural fate, right? And it is going to inhibit your BMP. Why? BMP, it is for your epidermis. Yes, Rubika. Right. So among them, which is going to be the correct answer? Yes. Richa, Rumi, Selva, Rubika, fantastic. It is going to be noggin. Okay, beta-catenin is the organizer inducer. D-shield will block your GSK3. But who is the original organizer that is going to block your BMP? It is going to be your noggin. Yes, right. Fantastic, everybody. So let's take the next question. The next question is seriously very, very important. Okay, so if font is little bit small, I'll read it for you. Sorry, next time I'll make it a little bit big for you. Okay, so the injection of noggin. So what they are doing? They are injecting noggin. So what is noggin? Noggin is an organizer. It is a dorsalizer. Okay, yes, definitely, Selva. So it is going to be an organizer. Dickenkopf, it is an organizer, but the role of Dickenkopf is not inhibiting your BMP protein. Okay, so Dickenkopf has a separate role. It is not working with the BMP. Okay, so other thing it is going to be inhibiting. Got it, Selva? Okay, so coming back here, this is going to be your noggin. You are injecting this noggin into the UV irradiated embryo. Okay, right. So this says that this noggin is secreted protein. It will induce your ectoderm to form the neural tissue. Okay, right. And it is going to dorsalize the mesodermal cells, which would otherwise contribute to the ventral mesoderm. Okay, got it? Is it clear? Dickenkopf is P-man organizer only, Selva. Got it? Okay, so now moving to the next question, everybody. So noggin is a secreted protein, correct? It induces your ectoderm to form the neural tissue. It will dorsalize your mesoderm. Otherwise, it is going to lead to the ventral mesoderm. All right. So next option. Noggin will bind with your BMP to prevent its complex formation with the receptor. Okay. The next one. Noggin with other molecules prevent the BMP from binding to and inducing this ectoderm and mesoderm cells near the organizer. Okay. Next one says that noggin is a secreted protein which induces to form the epidermis. Is it true? Think, everyone. Easily you can eliminate one fellow. Yes? Okay. Come on. So which should be the correct answer? Yes, everybody. As we are running short of time, I'm just jumping. Okay. Correct, everybody. Come on. So all other three are right. Only one it is going to be the wrong one. Isn't it? So absolutely it is, my God, where I went. Okay. So it is going to be your things. So noggin, it is a secreted protein. Yes. So it will form only your neural tissue. It is going to dorsalize. So first point is right. Yes. And the second point, it is right because it is going to bind with your BMP. What is wrong with the third point? Noggin prevent the BMP from binding to and it will induce your ectoderm. Is it so? Do you think that noggin will, yes, Tasnin, you think that noggin will make your ectoderm? Never, isn't it? So only your option 1 and 2 with B, it is going to be the correct answer. Got it, everybody? Okay, fantastic. Just a moment. Okay, so right. Just a moment, okay. This we are done with it already, I guess. Okay, fine. This question, this question you will take it as a homework. Take a screenshot. This question, take it as a homework. Fine. We will discuss in the next class. All right. Fine. So this is about the organizer only. Okay. If you want, we'll take it right away also. No worry. You want to do it now? We'll do it. Don't worry. Okay. So this induces the host ventral tissue to change the fate to form the neural tube. In case of amphibian, you have a Spearman organizer. So what is this organizer going to do? It will induce your host ventral fate to become the neural tube. The second one states that it cannot organize the host. It does not have the ability to differentiate into the mesoderm. It has the ability to initiate the movements of gastrulation. Both your beta-catenin and chordin are produced by organizer. Elimination helps. Seriously, I'll tell you, elimination will help. Do it now, do it now. Everybody in this class, we'll take each and every statement. We'll start with 5. Both your beta-catenin and chordin are produced by the organizer. True or false? Beta-catenin and your chordin are produced by the organizer. True or false? Yes, Pankaj. Good evening. Both your beta-catenin and chordin are produced by the organizer. True or false? First you eliminate this statement, then we'll go to the other ones. Tasmin is saying true, Rubika is true. What I told you about this beta-catenin. Who will secrete this beta-catenin? Beta-catenin is secreted by the Newcop center. Only accumulation happens in the dorsal mesoderm. Okay, so again and again I'm telling this point, very important point. Please don't get tricked. Beta-catenin, it is secreted by your endoderm. That is what is your Newcop center. Okay, endoderm is the Newcop center. It is only going to secrete your beta-catenin, but it is accumulated in your organizer. Where it is accumulated? In the organizer it is accumulated. Okay, organizer is not at all secreting this beta-catenin. So 5 you must eliminate. Got it? This is one of the trickiest point. That is why I just want to discuss here. Yes, Shubhra, Rumi, Selva, Rubika, Tasnin. Yes, everybody in this class. Pankaj, everybody got it? So 5 should be eliminated. Okay. So organizer, it has several functions. One such function is to initiate this movement of gastrulation. So 4 should be definitely there. And it does not have the ability to form dorsal is wrong. The main function is to form the dorsalizer. So this 3, it is wrong. Okay. So which is the only correct answer? A should be the correct answer. Got it, everybody? So now you understood this topic? Yes. So is this clear to you? Everybody in this class. Very good. Yes, Permal. Yes, Richa. Pankaj. Tasnin. So option A is only going to be the correct one. Please remember that beta-catenin, it is not at all a part of your organizer. It is inducing your organizer, but it is not the part of organizer. Got it? I hope that this is all clear to you. Okay, so there is some interesting information. Yes, so you have a mock test for your CSIR NET. So it is falling on Sunday, August 28th. Okay, so if you crack this and you get this rank 1, you will have a voucher for 15,000. Not for the voucher, you will get a good practice of questions for our life science. Okay, so don't miss out to take the test. Yes, it is curated by us. So you will have a detailed thing on that. And upcoming September 1st, we are launching a new batch. It is called as Bio Beakers. Okay, so in that also we are going to take a complete batch of CSIR syllabus. I will be dealing with Unit 2, Unit 10, Unit 11, Unit 3. Okay, in this batch. So don't forget to enroll yourself for this. We have some exciting offers that is being running on. Yes, so you are getting a 20% off on the overall fees. So this offer is ending by today. Okay, so you can use my code Saranya Live such that you get this offer, and iconic subscriptions are going to be very soon beneficial because we'll be getting the study material through this. Yes, so it is very, very close. So don't forget to subscribe. So if at all you find something inappropriate, please do report me. Okay, fine guys. So that's all for the day. All the very best. Keep learning, keep revising, and I really want everybody to crack the examination this time. All right. Thanks a lot, guys. Take care. I'll see you tomorrow in the next class, that is Monday by 6 p.m. Okay, guys. Keep watching, keep sharing, keep liking.